Are you sure? Can you double confirm with this? Can you provide us with more example things like that? Yeah. So definitely, here in Malaysia, the lecture notes is built on top of our reference book. So all of the content inside is coming from our reference book. So if you wish to know about the citation or maybe the sources, you can refer to our lecture, the reading materials. That's it. Yeah. So I also appreciate if you can, like, if you know something, you can tell us, so that we learn from each other. Next one, use positive languages. So examples are for our friends, you are not able to join us on time, or maybe you coming to the lecture not so early. Maybe you come early. You know what I mean, isn't it? Like, instead of coming late, late negative. Next time, be punctual on the assignment submission and also class attendance. This is the four big rules for my classes, no matter it is lecture or the practical. Chapter 1's Introduction to Image Processing. The table of content, we're going to start with the what is digital image processing and proceed with the example and also some fundamental things. We start with the first one, introduction. So imagine I have an image like this, and towards the entire semester, the image that I'm referring to is referring to the digital images. That means the image is naturally born digital way. So imagine this is the image, and everybody knows that, or perhaps you know about this. Image is represented by numbers because computer do not understand so-called images. Just like natural language processing, computer do not understand what does it mean by the word LOFE. They understand numerically. So if I convert this image into a number, we will get a two times multi-dimensional images. Let's say this image is 500 times 200. This is the size, this is the dimension, this is in Python shape, shape, sizes. What is the size? 500, 200s. And for your information, the Cartesian plates that we are looking at is somehow different from what we know before this. Okay, give you some examples. And this could be the reason why the moment when I transfer a file to you online, sometimes the connection is being off. And the entire image that I transfer to you, they're having, okay, here still showing good. But after the connection is off, the image below will be distorted because we start transferring the image from the first pixel. Yeah? Next thing, so if I wish to know about the coordinate, the y-axis positive is going down. But normally what we know, the axis y-axis positive is going up. This is the basic difference between what we know and also the links for computer vision and also image processing. So here, I know that I have a thing called X and Y. So X and Y is the Cartesian plate, is the spatial plates that we know. Soon or later, you're going to hear me talk about a spatial and also frequency domain. Spatial, what we see, what we get. For example, if I'm looking at these greenish images, what I see is the size, the color. Okay, this is two things that I know. And this thing is called spatial. Something that we cannot see inside, for example, frequency. Throughout this one, how do I know that how many pixels having the pixel values of 245? That is something I cannot see. Yeah, and this is the difference between spatial and also another one, frequency domain. So I know that x and y is my coordinate of the location. F is the amplitude. So in our image here, mana ada amplitude? Where we're going to get amplitude? I thought amplitude is something like up and down, up and down. So in the image, if I put it a function f over x and y, this thing is referring to the intensity. If the thing is gray scale. Yeah, jot down a little bit. Grayscale world, we make use of intensity. How intense the grayscale it is black or white. Is super white or super black. Is 超级黑. Yeah, that is the intensity. You know what I mean, sir. Next, how about in the color world? Pixel value. Pixel value means I have three color channel. R, G, B. And here is the difference. In a normal world, an image or the color, the gaming mouse, look at whoa, there's RGB color, so nice. Great.
这个 recording 贴上去了。 Alright.
G going to the first one, red going to the last one. We're going to get RGB. But in OpenCV, these two things combined. B. So in any point of time, if we look the image in the OpenCV, the thing become bluish. You do the image become bluish. How come this person like an avatar one? Blue colors. That means the color channel of that particular images is not really compatible with OpenCV. So we need to shift the thing back. Convert. Okay, think about this. Maybank to you. Convert the Maybank to you. How can we convert the colors RGB to BGR? So we use a function of RGB to BGR under OpenCV. Yeah, that's the thing. And in fact, RGB is for display any devices related to lights. Example, monitor. Oh, monitor emit lights. Okay, RGB. Maybe laser pointer. Green color. This is also a light. Our mobile phone is the electronic devices emit lights, so they make use of RGB. Okay. Anything that produce color but not light, printer. They produce color, but they are not emit any lights. Yeah. Okay. That is the differences. The first one, I repeat, is on the Cartesian plates. The y-axis is the balik one, is the inverted one, upside down. And the second differences is on the color space that is being utilized by OpenCV and also image processing. Instead of RGB, I go for BGR. How to convert this thing? And the next question is, except for RGB, do I have other color space? Yes, for example, HSV. Yeah, one of the practical material is talking about I wish to detect the color of your shirt, let's say yellow color. In reality, ideally, if let's say my shirt is yellow color, in terms of in front of the camera, if I set it yellow color, let's say the pixel value is 254, 222, 100. If I set it things so precisely, can I retrieve the entire contour of the shirts or not? No, because ideally, yes, but in practical, when I put a yellow shirt in front of a camera, sure there's a lighting issues, this and that. In fact, if you're looking at our shirts, even on all of these chairs here, they comes with the ambient thing. Or they are yellow, they are dark yellow, light yellow, and also etc. So if I trying to set a range of the colors for the RGB or maybe the BGR, it is not going to work. So we need to set a threshold, a range. RGB define the colors based on 3 color channels. So I said, okay, if R,
let me say yellow, let's say, if I put when R is 200, green is 100, blue is 101. How about I said R is still 200, but green I turn to 101. This thing will remain the same. Next one I have this thing the same, I turn to this thing. And this story can continue for 2 hours because different combination is still producing a yellow just and yellow, also yellow, very dark yellow, very light yellow, and etc. So in that sense, it is not practical for us to set the control the color based on 3 color channels. A better way, combine these 3 things to use only 1 color channel, which is, and I have color space for action space. We're going to explore this thing on chapter 4, where the H is the only color channel to control the color. Yeah.
so far so good. Thank you. Okay, proceed. So here is a questions. This is a 2D function, f over x and y. X and y is a spatial place. What is the amplitude f in A and also B? For A, the function f over x and y will give us grayscale colors, will give us pixel value. Grayscale will give us intensity. Thank you so much. Proceed. Let's say this image is a 8-bit representation. I can tell you almost every single years of I'm referring to the final examinations. This question coming outside. In 8-bit representation, the pixel intensity value changes between 0 to 255. 0 is the black color, 255 is the white colors. So what is the formula that is going to be involved over here is 2 to the power of n.
Formula 2 over 8. I will get 2 and 6. But in pixel value, it starts with 0. So the maximum pixel value for these cases will be -1 and become -5. Yeah. In our naked eyes, can we see the difference between the image of 8-bit and also 7-bit? We cannot see the difference. Yeah, we cannot see the difference. One of my sibu, yeah, last time during Nazi time, we have this thing called Pusat Internet Satu Malaysia.
Long time ago lah, where I provide the training of Photoshop stuff to the manager levels of the working adults. So my Sifu can detect even one value different. Show you examples. Do not know it is something like a magical things. Going to the PowerPoint. Insert the shades here. Few colors, more colors. So right now the blue, this is blue color. So I know that the pixel value for blue colors is 130. Yeah. Across the RGB color channel, the blue is the dominant one. And that is why the image is in blue colors. So right now, I'm trying to duplicate another image and change the pixel value of blue color by 1. Let's see what is the difference. Can you see the difference? If you say yes, you are cheater, you are liar. We cannot see, we cannot see, but my Sifu can see. Sean, no. The second one, something wrong. They know the pixel value even by 1. Yeah, but I assume we are normal human. So we cannot see the difference. Alright. Okay, coming back into our things. Did you really spot the difference? Yes. Interesting. How many of you can spot the difference just now? The lipsticks, I do not want to argue with you. It's an endless story. Gentlemen, please support me. They're trying to argue they can differentiate their colors, the color code of the lipsticks. Okay, so if let's say an image, I let you know, I give you an image, that image is 3 bit. How many colors can be produced by that particular images?
How many colors can be produced by this? How about a maximum pixel value for this? terminate this image, how many colors we're going to ask you what is the maximum numbers of the color can you be produced by an image. Let's say the image is 8 bit 24. Okay. Now we move to the display console. Google. I don't know what to trigger you are. I'm not a fan of like Google or Apple, etc. But we're going to look at how the pixel works. But looking at the specs, let's see, Universe is Titan. Let's see, we go to this. Learn more. Text bench. I'm not sure they're still showing this or not because every single semester when I show this, sometimes they mention the people that was outside. Okay. This is the expect ratio. Yes. They mentioned about 24 bit gap. This also can indicate a wide range of color. How about okay, please allow me to give you provide extra informations. Even though the colors might be the same, but the final result will be different. Why? Because, for example, Samsung is coming from Korea, so we know that Korean people they are so emphasized on the appearance. That's why they do plastic surgery. Okay. So the display, people say that wow, Samsung screen very good. Why? Because they modified the number of the pixel on their screen and also their arrangement. Should I always arrange the pixel like RGB, RGB, RGB? No, they're going to arrange to be like RGBB, RGBB, RGBB. Why? Because blue color will make our eyes so comfortable. So if they increase the number of the pixel that can produce blue colors, it cheat our brain that wow, this display is so nice. Okay, this is their strategy. Or some of the manufacturer they did not put RGB, they put RBB G, RBB something something.
Yeah, okay, that is the marketing strategy so that we can produce a wide range of the colors on the devices. Okay, so we also can define, for example, is understand that the entire images is a large array, is a large matrix. So I can define from this small region like 645 to 650, 1323 to 1328, and I retrieve this thing. So the number here is actually a portion of the sub images coming from the main images. So if I can define this thing, I can change all of the pixel value by O plus 5. So the O overall, the intensity will be brighter. I also can change this thing. Let's say I have another image like the football. So the size of this, let's say is, how many are 1, 2, 3, 4, 6, 1, 2, 3, okay. 6 by 6. Another football images also 6 by 6. So I know that the pixel value of 6 by 6 of a football, I can tuck that. Then the football will be appears over here. This is one of the practical lesson for the Messi, for the football. Forwards, 8 bit 256, 5 bit, you know about the answer. 3 bits, you know about the answer. And the answer is this thing. Yeah, we do this just now already. No matter they are how many colors, the zero will be remain as the black colors, whereby the white color will be presented with their corresponding thing. Let's say for this thing, the white color is 255 minus 1. The white colors of this thing will be 31. Thank you. And this white will be 7. Okay. And the rest of the thing is going to be equally distributed among this. And the pixel value is always positive integer. Positive integer form 4, mathematics, modern maths, chapter 1. Integer, positive 1, 2, 3, 4, 5. Negative 1, 2, 3, 4, 5 here, all integer. But I'm referring to positive integer, UINT. U is referring to unsigned. Unsigned maksudnya, meaning that there is no any sign or symbol or anything in front. Which means that UINT, positive integers only. Yeah? We do this in the practical number 1 as well. Second, let us move to the what kind of field that is make use of digital image processing. Usually, past year question, chapter question 1, they ask you about like use case or application. Yeah. So examples in Wuhan, China, Huawei using the robot arms that combine with the computer vision and image processing to retrieve the product that they want. So you can literally buy a mobile phone, tablet, the earphone using this unmanned store. Yeah, why people develop such solution to their customer? Any ideas? Attractive, very good for marketing strategy. Did you know that over there is a store for us to buy? So they want to experience, but who knows when you experience that, you need to buy a new phone. They do this. Same thing happened in Singapore, Sentosa, Singapore. They're having this thing called the best, the most delicious omelettes produced by a robot arms. So you experience, you go to the Sentosa, you can try this machine. Yeah, one omelette things will cost us $20, Sing dollar, 20 Sing dollars, converted times 4. That is not most delicious and most expensive good. Yeah. Yeah, based on my definitions, I think that human develop such thing because of marketing strategy. We also do this thing because of human are lazy. I do not want daily repeat routine to be performed by my staff. In fact, it can be somehow replaced by the machine. So I put it there, the example of application, industry robots, autonomous vehicle, visual surveillance system, people counting, interaction between computer, machine, and also human. And here is the tips. If let's say question asked about like example of application, we're talking about use case. We do not talking about like Google Lens or Chat GPT. Yeah, the application here is referring to use case. We are in image processing. We are not in the mobile apps, mobile application developments. Second, looking at the autonomous vehicle, could be Tesla could be the pioneer in this industry. Back to 3 years ago, during NCO time, Tesla come to Shah Alam. They opened their their office in Shah Alam, and they're saying that they open for job applications. The position available is only 12, but the people queuing there 2,000. 2,000, 2K of people queuing. And one of my friends going there interview, they asked my friend the first question, do you know AI? And the second thing, can you do video processing or image processing? So this could be the thing. So what kind of technology is being involved there? Machine learning, image processing. We're going to identify where's the tree, where's the path, is there any human, things like that. Next one, automated watchdog. I wish to monitor the peoples here. Maybe because of I wish to know whether the space is large enough, what people is actually doing there. Are they walking? Are they running? Are they fighting each other? Yeah. So why we want to do this? Because our Malaysia also doing this. You may notice that in our MRT and also LRT station, our local government, the local council, they start installing camera. They want to monitor every single things. This is the thing invented during COVID-19 cases to measure the social distancing things between each other. If it's something that is within the threshold, they're going to trigger the alarms. Next thing, interaction between human. There is gaming things so, for entertainment purposes. Next thing, just imagine we have this face detection for attendance system. There is a camera there and you do not need to sign. Will it leading us to a better world? Maybe yes for management. How many of you staying PD9? Taking the attendance from your apartment is a very sexy package. I don't even need to wake up. I also can take my attendance. So nice. Next thing, exam proctoring system. There is a project between TAR UMT and also the ACCA in Indonesia, because they're trying to propose a platform where I can closely monitor the ACCA candidates. When they sit there answering the question online, there is a thing called exam proctoring system to continue to monitor the candidates. If let's say there are some people who come to you, or you taking a mobile phone, we detect a mobile phone within the frame, we're going to alert the thing. Okay? It's saying that important facial features are detected and else are ignored. Face detection is equal to object class detection. It is also attempt to solve a more general and difficult problems of multi-view face detection. Next one, digital video processing. If I get to know that there is a face, there is a hair, can I make my hair become red? Can I make my face become pimples free? Things like that. They are all possible. Yeah? Next one, remote sensing. Since we have the satellites out there, can I retrieve the image from the satellites? So this is a very crucial example. Why? Because I'm trying to monitor our ground's surface, but the camera here is a high resolution, super high resolution of the image, which is good. But when we wish to transfer this image back to the Earth station, am I going to transfer a file size which is, let's say, 20 MB? So as for these cases, the image compression should be applied. And for your information, image compression consists of two parts: lossless and also lossy. Yeah, lossless, that means quality there, everything good. Loss C, that means the file size is super small, but the clarity is no longer there. So we want it to be very high quality, just like we have the thing in lossless. But I want it the file size just being produced by lossy. There is a balance point in between that two. Next one, biomedical image enhancement and also analysis. I wish to figure out where is the location of the tumor. Yeah. CT scan, biomedical images, MRI, magnetic resonance images. So these are the two very common biomedical image file types for the medical images. So why the MRI and also the CT scan, they enable the doctors to take a look on this thing. In fact, the the devices cannot capture the internal parts like this, and that's why they inject something. The liquids inside will make the image become clearer. This is on the injection part. In terms of computer vision, I can make the certain region become larger. I also can segmentize that particular regions so that we can do the further analysis. Continue, watermarking and also steganography. There is a difference between these two. The difference is here. Our CLO1 theory and also image processing technique is rated at C4. C4 means comparison. So you may notice all of our past year question asking you to compare, differentiate. So next time, if you see my lecture notes showing comparison, you can put a hashtag or something, a star there already, because more or less that is the questions. Midterm or maybe the final examinations. Okay, looking at this, steganography is for us to protect the secret messages. Watermarking is protect on the image itself. Example,
Let's say I'm going to send this image. I am hospital A. I'm sending this image digitally via online or via any platform. And this image, when I send to the hospital B, in between this connection can be hacked. Why people want to hack? Because based on the statistics from Europe, up to 80% no income, so they're going to hospital. Makan. So our watermarking is going to come in. Not steganography, watermarking. Why? Which means that inside this image, I secretly embed something. For example, the logo Hospital A. I embed a logo inside here. Definitely human cannot see one as a watermarking. Nobody will see the visible watermarking copyright of the Hospital A and the water right corner. But we're talking about this thing is invisible. It means nothing can be detected using our naked eye. So when I'm sending this thing to the Hospital B is going to check. They're going to extract the watermarks. Oh, correct. Hospital A. So from here, I can prove that this image is not being tempered, is not being edited, is not being affected by any artist. And see, what if another cases? When I'm sending this to the Hospital B, in the middle of time, somebody retrieve this thing, or maybe the doctors itself edit this thing. There is no lesion, there is no white tumor, there is no tumor. But the doctor first he edit something, oh there is a tumor. So this type of edited image, where the information is being retrieved by Hospital B, they go to the X-ray. How come your logo has been tempered one? So we know already this is an indicator that this image has been tempered. Yeah. Whereby the state just now I'm explaining about the watermarking. Watermarking for us to protect the image itself. But steganography protect the message. Let's say today, same thing. I send over this image, something like a picture of a reference book. I send to my friend. But the secret message inside is, let's go wet tonight. Because my girlfriend will not allow her girlfriend to do so. So I secretly, I put a secret message, let's go wet tonight. At this thing, Mon Kiara, something like that. Yeah, let's say and the party B, my friend, that extract the secret message. Do you think this image is important? No, this is just a cover. What we want to know is the secret message inside. This is the difference between steganography and also watermarking. What is the usage of steganography? In fact, people get inspired from the Chinese people, the mooncake. Last time, when we wish to launch the attack, so I wish to send a secret message to the people inside the town. So they bring in this so-called food for the world. So when they open the mooncake inside, there is a secret message that let's launch the attack by tonight, 10:30 p.m. So when the people they open, mooncake not important. Secret the inside embedded inside is far more important than the hosting. So I'm saying that steganography is used for secret communication and watermarking is protect the host images. What is the secrets over here? I have the original image, I have the secret message where we define as the watermarks. Blend these two inside in, so on the outside, it is a normal images, but inside internally, when you buka inside, when you open inside, you discover something inside. So when you open inside, what you're going to be discovered inside? 我的真心。你会发现。Next, signature recognitions. Everybody can fake a signature.
What's wrong with
I
you
sign.
guys? Huh?
Hey, your features suppose your signatures, the curve is like that one. How come your curve right now different? So we can verify the signature whether it's correct or not. And for your information, the bank industry in Malaysia start implement this.
可能吗？
Last time you use the staff to check hey, your signature, how come different one? Sorry sir, would it be possible, can you sign this document once again? You need to same with the previous one. This route, no, because human judgment sometimes can be different. You say okay, I say no okay, and then gado. This route, what they do is they implement such signature recognitions. It's going to handle by machine, so that I know that you are the authentic person to sign this document or sign this statement. So how this thing is going to work? The algorithm, the common algorithm, definitely I do not know what algorithm that they are doing, but in terms of image processing, we call it as a FLANN. FLANN is inside our practical material. Try on that. So since like FLANN can check the similarity between two signatures, I also can use the FLANN to check the face similarity, whether are they the same. Yeah. Do I need a huge database? No, we do not need to. We do not need a thing called database. Imagine today the client come to the bank counter. The bank say, sorry, sir, we are now implementing the AI which is automatically verify your signature based on the database. Could you please sign your signature for 2,000 times? I need to do machine learning. The client said, you are siao, is it? Are you crazy? Because we understand that in order for us to do so, machine learning could be one of the possible solutions. But for the machine learning to learn from the previous pattern, you ask the client to sign 2,000, 500 times. No, they're not going to do so. So FLANN is not a deep learning, even though it ends with ANN. Yeah, it is an algorithm for us to check one document across another document, one to one, also going to work. Yeah. Following next, underwater image restoration and also enhancement. The original underwater images, it is unclear, it is greenish. Oh, I spoke some things here. RGB, no matter RGB or BGR, this image is suffering from green color. So if I wish to modify the intensity or the pixel value of the entire images, I should visit blue color channel, green or maybe red color channel. What do you think? Looking at this, this is more towards green or blue. Blue. You see this image green or blue? Huh? Okay, anyway, I'm trying to tell you, if the image is suffering from blue, we modify blue. If suffering for green, we modify green. Yeah, yeah, all right. So, B is something that we already process. C is after we process the color channel, can I enhance the rest of the color channel? For example, you see, there is a group of fish at the back here. After filtering, it become like black colors. And when I enhance the red color channel, I can see them very clearly. All these things is possible using the restoration by manipulating their color channels. That's it. For normally this is my jiaxiu. The thing that we brought it from the internet. We really buy that spot cameras or no? When we bring that camera, go to the underwater, what the hell? But the thing showing in the Lazada and Shopee, they're showing something like this. So this is the difference between enhancement and without enhancement. So between these 1, 2, 3, 4, column 1, column 2, which one you think is best? Some people say this, some people say this. No wonder I say Enhancement, no rules one. Enhancement, no government one. You say this one better, you go for this. You say this two better, you go for this. Again, image enhancement, very subjective. You choose which one you like. But restoration, meaning this is a pretty fixed one. In between these four and also these two, we are going to choose these four because the features is clear. I can see that the ground, is there anything there? There is a trunk, there is a sand, there is a stones over there. If compared to the before processing. So restoration is always needed because it helps us to remove the noise. Enhancement is something optional. We want to do it, we do not want to do it. They are possible. So what is the problem segments here? Well, underwater images suffering from the different problems such as blurring, non-uniform lighting, noises, or maybe low contrast. Right. Let us look at this video. I'm not sure whether it's going to work.
Have you ever wondered how the ocean would look like without water? Being able to remove this blue-green tint of the underwater pictures and still have the true colors of a coral reef? Well, using computer vision and machine learning algorithms, researchers from the University of Haifa were able to accomplish exactly that. Let's see how this works. This is WhatAI, and I share artificial intelligence news every week. If you are new to the channel and want to stay up to date, please consider subscribing to not miss any further news. Underwater photography is a challenging task. It requires expensive cameras, lights, all sorts of equipments, and a lot of skills. Even then, there is still a blue-greenish tint from the water covering the objects or animals in any pictures or video you will take. Fortunately for all the underwater enthusiasts, researchers from the University of Haifa were able to remove the water from these pictures and videos by using computer vision and machine learning algorithms. They call their new algorithm see-through. It takes an image algorithm.
By looking at this image before and after, can I say that the second images is not so good after we do the filtering? Maybe you're going to say yes because the color is totally different. So I'm trying to tell you that image enhancement is actually based on our objective. If my objective right now is to count the fishes, I don't care whether the color of the fish has been distorted or not. As long as I can see the thing, whatever thing that I do contribute to the machine to identify the fishes, that is a good thing. No matter what we do. If we do not want to do anything, also can, but the result might not be good lah. Yeah. So the output, even though it is not the same with what we see under the water, but it makes the objective achievable. It is a good uh, enhancements already.
They call their new algorithm see-through. It takes an image from underwater with the same blue-green tint and makes it look like it was photographed through the air instead of water. It doesn't only remove the color filter from the water, it also removes the visual distortion caused from the light travels underwater to accurately correct both the colors and physical aspects of the images. Let's dive a little deeper for all the machine learning enthusiasts that are wondering how this algorithm works. As I said, it takes an underwater image as input. But you don't
Underwater
even need
image
an
as an
expensive
input.
set of lights anymore, since it takes a raw image or even video with natural lighting. Normally, this was a big issue that is completely solved by this algorithm. Objects that are far away from the light source wouldn't get caught clearly by the camera.
Okay, you may notice just now they explained about like I take the raw image as an input. For machine learning or deep learning to work, I have the input image. I have a thing called features. What is the features here? Input, then what is the features? The simple way out is we're going to tell the machine, hey, next time you see the blue color like that, like that, like that, like that, you turn into red color like that, like that, like that, like that. So I have the input, I have the output, I have the features, I have the output. So same thing happened with this thing. If I know that, underwater, the sand, S-A-N-D, the sand is not green or blue like that. So I define all this color range, the output, you turn to white color. And that is the simple way out. We do this thing called intensity slicing. This color range, slide all this thing, put it white color. Oh, the star there or the Nemo there, they are not, the color is not going to be like that. Then we change a little bit. If I notice that the green underwater plant already good, do I need to map into a new color space? Tak payah lor. And this is how we're going to do in terms of AI. Okay, I will stop this thing. If you want to watch this video, you can from your PDF, click the text below. It links to you to the YouTube links. Next thing, optical character recognitions. For your information, our assignment topic 1, if I'm not mistaken, that is the problem statement coming from DSA. Yeah, the president instruct the DSA and also FOCS to look some solution like this. Imagine right now, this is the graduation ceremony, and this thing usually happen. It happen almost in every single graduation thing. Student queue there, they take their barcode, and the staff, they have a physical list. So the list, suppose, is the same with the student queuing sequence. So on that paper, the staff is going to read the name. This is in the correct order. What if the student, hey, I go in front of you, I want to queue with my twins so that we can next to each other. So this thing always happen one. Or sometimes they forget, they do not come to the rehearsal. And the student change. So the things inside the computer, they're going to press next, 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 next. So next, the student name there, they're going to read their name. Peter Heng Ji Wang, Bachelor's of Software Engineering, things like that. But the name displayed on top is totally different with the guy. So if one person is wrong, then the rest, they're going to be like stop. So the start there will be due to the technical issue. I don't know. Yeah. How can we help them to solve? Maybe we're going to do the face recognitions. Is it the people queuing here is the same with my system? Don't expect machine learning is going to work for us. Are you willing to go to the DSA, take photo 1,000 times? Smile, not smile, smile, not smile. No. So by providing one single images, you can make use of your student card. Only one image. See whether these two things is similar or not. Now you think about the FLANN or any possible solution for us, as long as you check the similarity between one image to another image. So next time, student Q, capture the camera. Are you the same with my database? If yes, please make use of what everything that you already learned. Maybe you take NLP, maybe you did not take NLP. Maybe you know LLM, you use LLM. How to use? When the people come, they queue in, everything is validated. Face scanning, first layer. Second layer, maybe the QR code in their hand. I scan, I display the name, and the system will read your name precisely. Tan Ji Wee,
Bachelor of Software Engineering in something, things like that. Okay, that is the assignment topics. Huh? So how do we make use, do we recognize the text from a hard copy? We call it as optical character recognitions. And the most common one is called tesseract. Can we put somewhere? It's called tesseract. Known as OCR. We can use this thing to extract the text whether it is written or printed. The tesseract is spelled as. Tesseract is a library for us to extract the text from the digital copy. Tesseract. So Tesseract is developed by HP and later brought over by Google. If the product brought over by Google, you know how powerful the thing is. Yeah. So Google brought over, make it open source. So happy, we love open source. Okay, I stop somewhere here. We go for a 5-minute breaks. In between, do you have any question to ask?
For me.